Okay, now we are still on the ideas of the traders and then a car or a tractor. So, as we saw, I told you, let me give you a simple example here. When I have these two, one, this is going to be the tractor and this is going to be the trader. The trader is one always which is behind because it's always trading. Trading means to be behind. So, when this one is driving, of course, there is that which is connecting these two. So, we call it, sometimes they call it a toe, or sometimes they call it a cap. So when this one is driving, this one is driving, it's going to be pulling this one behind. So that's always the idea. So always there's some tension that is going to be between these two acting into this toe that is joining them. So always this one which is driving is what we call a cap, and then this one which is they are pulling is what we call a trader. So see, as I drive, you see? Okay, so after having that, let us come to the question. After doing between the trader and then the tractor. The tractor of mass 700 kilograms pulls a trader, I think you know what the trader is, of mass 300 kilograms along a straight level road. The total resistance in motion is the 1500 newtons, or you can call it 1500 or 1500 newtons, it's up to you. And the tractor is using a full power of this. So that our power is given in kilowatts. So what we do is first convert to watts by multiplying it with 1000, because 1 kilowatt has 1000 watts. Show that when the tractor speed is 36 kilometers per hour, it's also registered in kilometers per hour, yet hours is always in meters per second. You also do that. We convert this now to meters per second. Its acceleration is 1.5 meters per second, so that's handle part A. So now, let me draw a level ground where I have those two, the tractor. I have my tractor here. This is going to be my tractor. You don't need to put a tractor and then you start shading, and so this is not art. We are just illustrating. Okay, so I have a tractor, so this is going to be my tractor. So this is my tractor. It has a mass of 700 kilograms. Then a trader is having 300 kilograms. Of course, now if we have the force and then the power and then the velocity, we can know the tractive force, and it's going to be pulling that car forward. And then how do we get a tractive force? From y equal to force times velocity, we want this force that is pulling the car forward. It's going to be now power divided by the velocity at which that unit is working or that the car is moving. So we get the power divided by this, we get 3,000 newtons. So meaning the force that is going to be driving, this is going to be 3,000 newtons, or what we call the tractive force. Remember, we are having these two are connected, so we are going to be adding some tension in them there to there. But remember, they told us that as this one is moving, of course it will experience some resistance. Let us call it R1. And then as also this is moving, it will experience some resistance R2. Okay, so as long as we have that, the rest are going to be very easy. Now, the direction of acceleration we're expecting is going to be in that order. So that's where the acceleration is going to be. If the velocity is not... Okay. Now, from there, because we're going to be adding some acceleration. So from there, what happens? So then we need to get the acceleration. So there are two ways. You can either consider this mass, this and this as one, and then the actual resistance is this, or you can handle this separate and then this separate. So this is going to be our trader, and this is going to be our tractor. So because we are not talking about friction specifically, then that's why I'm not using the reactions. Okay, so when I come to the trader, based on the direction of acceleration in that order, I think you can see. So what is pulling it in that direction, this trader is going to be, you know that always, our resultant force is equal to M times F. So what's pulling it in that direction? We have this, you said something which is pulling it in that direction of acceleration. So T, then minus this resistance R1. R2 equaling to its mass, which is 300, then times the acceleration. And we call this equation 1. Then we come now to our tractor. Our tractor still is accelerating in that direction also. Remember, our resultant force is equal to MA. What's pulling it in that direction is this, which is 300, then minus this T. It will be equal to the mass, which is 700, then times the acceleration. But of course, because we have something which is opposing, so we shall also get off that resistance also. This resistance here, that is this vehicle is facing, the tractor is facing, and it's moving. Okay, so this T, then minus this R1 equaling to 700 times acceleration. So from there, you can see we have this and we have this. What can we do? Eliminate these two. So we can call this 3000 minus T minus R1 equaling 700 equation 2. So we can add 1 plus 2. So if we add 1 plus 2, we have T minus R2 equaling 308. When I add this, I'll be having, let me start with this, negative T minus R1 plus 3,000 equaling to 708. If we add these two, let us see what happens. This plus this goes to 0, this plus this, so I'll be having negative R1 plus R2, then plus 0 plus 3,000, I have that, equaling to 1,000 acceleration. But remember, they told us that the total resistance, total resistance in motion is that. But R1 plus R2 is going to be 150. So we put it there, 150 plus 3,000 to be giving us 1,008. And from there, our acceleration is going to be, we get this, I think so we are going to be having 1,500 divided by 1,000, this minus this, we get 1,500 divided by this, and get 1.5 meters per second squared, and that's the acceleration. The other easier method is you combine this as 1, you'll be having the whole force as 1,000, then the resistance this and this was given as this. So you say this in direction of that, we say the force that is going to be driving, we say this minus the resistance, which is 1,500 is equal to the mass, the total mass, times the acceleration. That's the other way you can handle that question. I wanted to take you through this so that you can see how it also works. Okay, then in part B, they are telling us that assume that the resistive force is divided between the trailer and then the tractor in the ratios of their masses. Find the tension in the coupling between the trailers. So one has to get this tension. So they're telling us that the resistive force is divided between the trailer and then the tractor in the ratios of their masses. So here, remember this one is having R1. So in their ratios, R1 over R2, the resistive. This one is resisted by R2, this one by R1. So they are divided in their ratios. So this will be now 700 over 300. And then you can able see that from there, my R1 will be equal to 7 over 3 R2. After getting that, it means that now I can get now what each resistance, what each of these is facing as its resistance. How? Because I know from R1 plus R2 equaling to 100. Why? Because they told us that the total resistance is 1500 or 1500. So if I put where is this, I put this, I'll be having now, from here I have now 7 over 3 R2 plus R2 equaling 1500. When we take this side, we shall have, okay, multiply through by, when we add this to this, we shall have this 10 over 3. This and this we get 3. So we have 10R3 over 3 equaling 150. So my R2 becomes, this time this divided by 10. When I multiply this by 3 divided by 10, I'll be getting 450. And these are going to be newtons. Okay, now from there, we can come and get our R1. Our R1, which is 7 over 3 times now 450. So our R1 is going to be 1050 newtons. That's going to be now my resistance. Now this one is facing this resistance, of course, because of its weight. It has to be having resistance, and then this one has this as its resistance. Okay, find the tension in the, so they want me now to get the tension here. So you can either use this or this, but this one I think is easier. So from one, this one, T minus R2 equaling to 308. But now my tension is going to be 300 into our solution, which is 1.5, then plus R2, my R2, which is 450. And from here, my tension is going to be 900 newtons. As simple as that. So, meaning that now, here, if we have this resistance and this, then the tension in the string, not the string, the tension in that steel rod that is connecting this trailer to the tractor is going to be 900 newtons. So, that's how we had to handle that question. I wish you well.